In this video, I'm going to show you how to use a brand new feature that I added to the Polars extensions library. In version 1.1.1 of Polars extensions, I developed the Read XML function. Admittedly, this is a very niche function, but it's likely that you'll have to work with XML data at some point in your data career, so let me show you how useful and powerful this tool can be. Before going on, I want to invite you to clone the Polars Codecademy repo on GitHub. Doing so will give you access to Jupyter notebooks and the data that we use in all of our videos here on the channel. Okay, so in prior videos, we covered the JSON normalize function, which enabled us to flatten nested and complex JSON data structures. And it would move it into and normalize it into a tabular format. Now, the Read XML function essentially does the same thing, but for XML data. Now, this function gives you a lot of control over how you read and flatten XML data. So we'll walk through several parameters and examples. We're going to come over here to our Jupyter notebook. And you can see we've got several different sections here. The first thing that we're going to go through are the default arguments or parameters that are passed within the Read XML function. Now, we do have several other items that we'll kind of walk through as we go through, but let's expand this one here. And so just another note, you're going to have to make sure you have Polars extensions version 1.1.1 or greater installed on your computer. And then we're going to invoke the PLX library, and then we're going to use the read XML command here. Now, we don't necessarily need to, at this point, import the Polars package because this function on its own actually imports it and uses it. So no need to actually import Polars as PL in this case. Other cases, you probably will need to do that. Okay, now, before we actually read this XML file, I want us to take a look at it here so you can kind of get an idea of what this file looks like. Now, you can see we've got a catalog here. It's got two products in it. And there are several layers here where data has been nested inside different sections. A couple other things I want to point out here is that there's some attributes within these elements here. So product has a SKU, an available attribute here, as well as this price one has a currency. So that's going to come into play a little bit later. But let's go ahead and head back to our Jupyter notebook, and we're going to read this into our data frame. Okay, so we've got 6 columns here. You can see it took, excuse me, you can see it took the structure and it flattened it out into a tabular format. It went and it kind of went through all the levels, made it on one level. And so you can see kind of the path that it took to get to each of those. So we've got catalog, product, SKU. And so these are basically the paths that we took to get to the very bottom of the nesting level. All right, so there is 6 columns here. Some of them are duplicating. You can see we've got some duplicate rows here. The main reason for that is due to the final layer here where we're pulling in the features, and it looks like we have 3 features on one product and 2 features on another product. This is definitely a step in the right direction. We have an idea of what data is in here. It's a little bit easier to read in this format. Granted, it's not normalized. You would have to go through after the fact, do some more Polars calculations to make it more normalized so you get the unique product SKUs and product names and all that stuff. But it's a good start. Okay, we're going to go to the next one here, which is the flatten parameter. Now, by default, you could see that it was flattened, right? And probably what I should have done is hovered over here so you can see all the defaults. So flatten is set to true in this case. We also have include attributes set to true. And then we have a couple other parameters here, strict, as well as some other items there. So let's go ahead now and see what happens when we use the flatten is equal to false. So previously, it was going to the furthest level in, it was extracting it, flattening it. Now we're telling it, don't do that, just go ahead and start with the main level and go to that point. So let's go ahead and see what that brings back here. Okay, so we get back 1 column, right, which may not be the most helpful. But what it does do is it puts it into a Polars data frame that you can then work with yourself, right? So there's list and structure objects in here. There are Polars functions that allow you to unnest and break these things out, get rid of that structure that's in there. And you can do some custom manipulation here if the flattening doesn't quite work the way that you're expecting it to. So that's what that parameter does. We're going to go to our next one here, which is includes attributes. Now, once again, include attributes is set to true by default. And what this one is looking for is flattening and pulling out the data from the attributes. So that is anything here in light blue. These are considered attributes. And so it's pulling out all this data as well by default. But if you wanted to exclude that, maybe that's not really data that you need, or it's just causing too much clutter, you can go ahead and pass the include attributes parameter here, set it equal to false. And when we run the code, you can see that it removes those items from our data frame. Now, it does still duplicate the data, but now we only have 3 columns as opposed to the 6 that we had previously. Okay, so that is an option for you. Let's move on to the record path. Okay, so the record path parameter is probably one of the most useful for nesting and kind of providing a little bit more control for you, at least from the get-go. So this one, essentially we follow a path and we tell the Read XML function to start unpacking the data at a certain point within the path, right? So in this case, we're going to say catalog.product.features, and you do have to kind of use the dots there to unpack it correctly. And those correspond to the different tags that we have here, right? So we've got catalog.product, right? So catalog, product, and then features. And so what we're going to tell it in this case is to go to this level and extract that data, right? So let's see what that does here. I'm going to go ahead and run that. Okay, and we get back another Polars data frame, and it has the 5 unique features that are within the XML file. Now, this might be helpful in some cases. In this case, it doesn't really make a lot of sense because we want to link those features to a specific product. Nonetheless, it's a powerful function in the sense that it allows you to go to a certain point, extract the data from there. We've got another example here where we're going to the product level, and we're going to show you what that looks like. Okay, so when we run that, we get all of our features again because it's going to normalize and unpack everything from that point. But then it's also going to grab all this data here. Okay, one thing that we can maybe try, let's do this on the fly because I didn't plan for this, but maybe if we set flatten equal to false, I do want to see what it does here, if it will give us the unique product names, and it does, right? So it does give us, in this case, unique values. This is maybe a more useful way of looking at this data, right? Because you're removing all those duplicates. Now, it does have all these in it's kind of packaged up. You still will probably need to unpack these. Maybe you could select these columns, unpack them. But it gives you a little bit of flexibility with working with data. Again, similar to this argument up here where you don't flatten the data, there are Polars functions that you can use to unpack lists and structures and all sorts of stuff like that. So if it's not quite working the way you're expecting, you can at least get it into a data frame that you can then work with it and kind of make it easier to handle the XML data. Okay, this last functionality here is not really a test of functionality per se, but just another way to read in data from this read XML function. So you can use files, which is what we used for a majority of this video. But if you're reading from an API, or if you have a declared variable within Python that you want to pass in, you can do that as well. If you hover over here, you can see that it accepts either a string or bytes, which bytes would be the file. So either way you want to do XML data loading, you can use the string, you can use the file path. So anyway, nothing really new here. This is the exact same XML file. If we run this, we're going to get our 6 columns back. We've kind of come full circle here, and now we have data frames from XML data. Alrighty, I hope you liked this video. I will say that I use this in my job. I developed it for that purpose. You think that a lot of people, when they use data, they're going to use CSV files. JSON is usually a better standard than XML these days, but there are quite a few systems that still leverage and utilize XML. So this just gives you some more tools in your toolkit to handle data, and hope you found this video insightful, helpful, but I'll leave it there, and we'll catch up with you at the next one.